Welcome to The Explainer. Today, we're going to unpack the complex world of AI engineering. We'll do it by building a clear mental model of the modern AI tech stack, piece by piece. We hear about the incredible promise of AI all the time. But what happens when it goes wrong? The stakes are unbelievably high, especially when our own human biases get baked right into the algorithms, just like this headline shows. And these failures, they aren't just happening on a screen. They can have devastating consequences out here in the physical world, causing very real harm. And it happens even when security systems, the very things designed to protect us, are fooled this easily. All of these incidents really hammer home why a solid, robust engineering discipline is absolutely crucial. Okay, so to get our heads around this, let's use an analogy. Think of the AI stack like a skyscraper. We're going to build our understanding from the ground up, layer by layer, because if any one floor is weak, the whole thing is at risk.
Every skyscraper, of course, starts with a solid foundation. For AI, that foundation is built on two things: data and the infrastructure that holds it all up.
The entire process really kicks off with data. First, you have to collect it from, everywhere. APIs, databases, you name it. Then you need a massive, scalable place to store it, something like Amazon's S3. But honestly, the most critical step is the preparation. This is where you clean up all the messy, raw data and turn it into high-quality fuel for your model. If you get this wrong, the entire structure is unstable from the start. All of this data work runs on a bedrock of some seriously powerful infrastructure. You've got the raw computing power from cloud giants like AWS and Google. Then there are these critical tools like Docker, which neatly packages your code into a consistent little box. And Kubernetes, which is kind of like the air traffic controller that manages all those boxes at a massive scale. All right, let's move up to the next floor and see how this all builds up. With that solid foundation in place, we can start building the core structure. The models that are literally the brains of our AI. Now, when it comes to building these models, one language pretty much rules them all: Python. And this quote here really hits the nail on the head. Its simplicity lets engineers focus on the actual problem they're trying to solve, not on fighting with complicated code. And the huge ecosystem of libraries around it, that's what makes it a real powerhouse. So within that Python world, a few key frameworks really dominate the scene. You've got TensorFlow, which is Google's workhorse. It uses what's called a static graph, which means it's all planned out and super efficient for production. Then you have PyTorch, which is famous for its dynamic graph. That gives researchers the flexibility to kind of experiment and change things on the fly. And if you just want to build something really fast, Keras gives you a simple, user-friendly layer right on top. Beyond those big frameworks, the modern AI engineer's toolkit is just full of these specialized libraries. Hugging Face is like a giant app store for pre-trained models. It saves you so much time. Frameworks like LangChain are basically the plumbing that connects powerful language models to your own private data. And then you have these things called vector databases like ChromaDB. They are absolutely essential for giving AI long-term memory and the ability to search based on meaning, not just keywords. It's a real game changer. A skyscraper isn't just a frame, right? It needs plumbing, electricity, elevators, all the systems that make it actually usable. In the world of AI, this is MLOps. It's the stuff that makes a model reliable and useful in the real world. And that's exactly what MLOps is all about. It takes the messy, experimental process of building a model and applies the discipline of software engineering to it. It's what turns a fragile prototype, a cool science project, into a scalable, reliable product. It does this by automating the entire life cycle, from development all the way to monitoring it out in the wild. And this is where the full-stack AI engineer becomes so vital. They are the glue, the bridge between that theoretical model and a product someone can actually use. They're the ones building the APIs and the user interfaces that bring all that AI intelligence to you and me. The MLOps landscape is just packed with these specialized tools that solve very specific headaches. So, for instance, how do you keep track of hundreds of different model experiments? Use a tool like weights and biases. How do you actually get your finished model running in a live production environment? That's what something like Seldon Core is for. And how do you tie all of these different steps together automatically? That's a job for an orchestrator like Apache Airflow. Okay, finally, we reach the top of our skyscraper. And up here, we have to consider the people who will actually use it and the safety codes that are there to protect them. This is what we call responsible AI. Remember those failures we talked about at the beginning? One of the single biggest dangers with AI is that models don't just learn from data, they actually amplify its flaws. It's like that classic engineering principle, garbage in, garbage out, but with AI, it's more like garbage in, garbage amplified out. If you feed a model biased data, you are guaranteed to get biased results. That Amazon hiring tool is the classic example. It started penalizing resumes from female applicants. And why? Because it was trained on a decade's worth of hiring data from a tech industry that was, and still is, dominated by men. The AI just learned the patterns it was shown.
What's so fascinating here is that this one failure reveals several different kinds of bias, all working together. You have historical bias, because the data reflected the past. You have representation bias, because there just wasn't enough data on female applicants to begin with. And then you have aggregation bias, where a one-size-fits-all approach ended up unfairly penalizing entire groups, like, for instance, graduates from all-women's colleges.
So how do we fix this? The good news is engineers are building tools specifically to fight this kind of bias. IBM's AI Fairness 360 is like a diagnostic kit with dozens of metrics to find and fix fairness issues. And Google's What If tool is even more hands-on. It lets you visually poke and prod your model, asking what if this data point were different, so you can see exactly where the weak spots are. Beyond just tools, there's a huge movement towards transparency. And one of the best ideas to come out of this is the model card. Think of it just like a nutrition label, but for an AI model. It forces the creators to be upfront about how a model should be used, how well it performs, and, most importantly, what its limitations and potential risks are. And that leads us to a final, and I think really crucial question. As the tools for building our AI skyscraper get better and easier to use, the real challenge is no longer can we build it, but should we? The best engineers won't just be the master builders, they'll be the ones who have the wisdom to ask the tough questions about what they're building and why. Thanks for joining us on The Explainer.